Okay, this is a tutorial on applying trig ratios and right triangle trig to real world scenarios. One of the first concepts that we need to make sure we drive home with you is this idea of angle of elevation and angle of depression. Okay, so if you look at this picture that we've provided for you here, we've got a battleship in the water and a jet that is up in the air that eventually will maybe land on this battleship. And so angle of depression and angle of elevation is all about perspective. So where you are and where are you looking. So first we'll talk about the angle of elevation. Angle of elevation is when you are looking up and finding something above you that you're looking at. So there's two lines of sight that meet at your eyes. That's where you look out directly ahead of you, and then you look up to whatever you're looking at. And those two angles will make those two lines of sight, I should say, those two lines of sight. So for instance, let me just drive this point home here. If this is you, there's a line of sight from your eyes that goes straight out and a line of sight from your eyes that go up to whatever the object is that you're looking at. This angle here is the angle that we're talking about. So these lines of sight here and here. So when you're looking up, that's called the angle of elevation. If you're looking down, so say you're above something, your line of sight is out and then down to whatever you're looking at. This angle here that we're talking about, that will be the angle of depression. So if you're in this jet and you look out and then you look down at the battleship that you're looking at, this angle here, that's what we're talking about, the angle of depression. If you were on the deck of the battleship and you're looking up at the jet, that's what we're talking about here. You look out, you look up, that's our angle of elevation. Now, the idea here is that because these two lines of sight are parallel, alternate interior angles are congruent, and angle of depression and angle of elevation make this zigzag here, and they are indeed congruent. Now, one of the important things that you need to see right here is in this right triangle. Notice that the angle of depression is actually outside the triangle, and the angle of elevation is inside the triangle. Keep that in mind. It's not this angle here. That's definitely not what we're talking about. It's this angle that's outside, so that you can see here that they are indeed congruent with that alternate interior angles, but it's not this angle here. A lot of times people will make the mistake to say that this angle, the other acute angle in the triangle, is the angle of depression. It is not. The angle of depression is actually outside of this triangle. So we're going to apply this idea of angle of elevation or angle of depression to a couple of real world scenarios, and we want to make sure that we pick the correct trig ratio that we would use. All right, so here's a little bit of practice to just make sure that we pick the correct trig ratio. So again, relative to this angle right here, our acute angle that we know, this would be the opposite leg, this would be the adjacent leg according to our SOHCAHTOA. One of these ratios is opposite and adjacent, that would be our tangent. Next, in this scenario here, we're again focused on the acute angle that I know. This is my opposite leg. That's the hypotenuse because it would be across from this right angle here. So opposite and hypotenuse is going to be my sine ratio. So this would be sine. And then finally, focused on this angle here. This would be my opposite leg and this would be my adjacent leg. So that's another tangent ratio. And you could see that if I was focused on this angle, I'd be focused on an angle outside of our triangle, but alternate interior angles makes us know that that's 26 because of alternate interior angles are congruent. And again, that's a right angle because we measure height perpendicular to the ground. Okay, in this video, I'm going to do a few examples with you just so you have kind of an idea of the process to go about solving these word problem real world scenarios. So here we go. Here's our scenario. When an airplane starts to descend, so we've got some airplane, and bear with my art. Airplane is heading down toward the ground, and it is 10.5 kilometers away from the airport. So airports are down here on the ground. So I'm headed down toward that. So this distance that I am away, that I'm traveling, this right here, that's 10 30.5 kilometers. Okay? It says from the angle, and the angle of depression, so that means I look out and I look down. That's this angle right here. That angle is 30.1 degrees. And I want to determine the altitude, and altitude is another word for height. Now remember, height is perpendicular to the ground, so this is my height that I'm looking for here. Alright, well, the piece of information that I have right now is the angle of depression. Now that's outside my triangle that I'm interested in, so it doesn't directly help me with my height, but I remember that the angle of depression and this angle here, the angle of elevation, alternate interior angles, makes them congruent. So this angle right here is 30.1. Now everything can be calculated, or everything can be identified relative to the acute angle that I know. So relative to that 30.1 angle, this would be the opposite leg, at 10.5 would be the hypotenuse. So as part of my SOHCAHTOA, opposite and hypotenuse is sine. So the sine of the acute angle that I know, 30.1, is the opposite leg, which is h in this case, and the hypotenuse 10.5. So again, I had to use the parts that I was given to pick my ratio, and then I set up my equation. Now you want to use your calculator. Make sure you're in degree mode in order to figure out what the sine of 30.1 is. So my calculator tells me that the sine of 30.1 is 0.50. So now I want to solve for this height. So I multiply both sides by 10.5. And the height is going to be 5.25, and that's kilometers. So how high above the ground is this airplane when it starts to descend? Is 5.25 kilometers. All right, next we're going to try this next example. A jet took off at a rate of 280 feet per second and climbed in a straight path 4.5 minutes. What was the angle of elevation of its path if its final altitude was 16,500 feet? Now, this is one of those problems where they give you more information than you need. So let's draw our picture and identify so we can pick out the information that is helpful and get that away from the stuff that's not helpful. Okay, so we've got a plane taking off this time, and we're heading up to an altitude of 16,500. Now remember, altitude is measured perpendicular to the ground. So when I got to this point here, it was 16,500 feet off the ground. Now that's something that a lot of people can make a mistake on. They might say that it traveled 16,500 feet in this path, when the reality is its altitude is measured straight up and down. So they didn't actually give us how far it actually flew. They gave us the measurement of where it ended, how high above the ground that was. All right. Now it says it took off at a rate of 280 feet per second and climbed in a straight path for 4.5 minutes. So what we're going to have to do is we're going to have to do a little bit of a side calculation here of 280 feet per second and 4.5 minutes. So first things first, I've got to convert minutes to seconds. Okay, so what I did is 4.5 minutes times 60 seconds per each minute. So 4.5 times 60 tells me there are 270 seconds in 4.5 minutes. Then what I've got to do is say, okay, it was traveling 280 feet per every single second. So it went up 280 feet times 270 seconds. So according to my calculator, 280 times 270 is 75,600, and that'll be feet. So I traveled that far overall so I could get up to altitude of 16,500. So that means from the ground, diagonally up into the ground, because I don't fly straight up and down perpendicular. I have to go gradually diagonally, tracing the hypotenuse of this triangle. That was 75,600 feet. So now I know what the length of my hypotenuse is, and I know what the altitude that I will be at eventually. And what they want to know is, what is the angle of elevation? Now remember that the angle of elevation is in my triangle because it's look out and look up. So that's this angle here. Again, I put an X because I don't know what that is, and that's what I'm looking for. So I'm going to use trig ratios to help me solve for this. Okay, everything's going to be relative to that angle that I don't know. So this would be across from the acute angle. That would be my opposite leg, and this is across from the right angle, so that's the hypotenuse. According to SOHCAHTOA, my trig ratio that I would be interested in is the one that has opposite and hypotenuse in it. That's going to be sine. So the sine of the angle that I know, x, and is the opposite leg over the hypotenuse. So now what I'm going to end up having to do is do inverse in order to find what x is. So I take the inverse sine of both sides, and that's going to help me figure out what my angle measure is that I'm looking for. So these cancel. I've got x by itself, and now I go to my calculator for the result. Calculator, the inverse sine of 16,500 over 75,600 is 12.61 degrees. So this angle that I was flying at, that I was climbing up to that height of 16,500, that altitude was 12.61 degrees. Finish on this example here, number 4 on your notes. A wooden beam 24 feet long leans against the wall. So we'll say that this is our wall here, and there's the wooden beam that is 24 feet long. Okay, it makes a 71-degree angle with the ground. So that means here the beam and the ground touch at a 71-degree angle. How high up the wall does the beam reach? Well, height is going to be this vertical leg here. Okay, so relative to this angle here, this would be my opposite, this would be my hypotenuse, so that's going to be, according to SOHCAHTOA, that's going to be sine. So the sine of the angle that I know, 71, is the opposite leg over the hypotenuse, and I can go ahead and turn this into a proportion. Cross multiply 24 times the sine of 71 is 1 times x, or x. So I type that into my calculator, and I get 22.69 feet. And just to double check that this is a reasonable answer, that is a leg, but it is shorter than my hypotenuse, and we've got to make sure that our hypotenuse is indeed the longest side of my right triangle, or this would not be accurate.